Ladies and gentlemen, boys and girls, welcome to another episode hosted by none other than the incredible academic. Guys, look, compliments for the new year. This video is being recorded on the 1st of January 2024, right? So I hope you guys are crossed over nicely so, and I hope you guys are ready to crash 2024. Yes, so we're not gonna waste much time. Let's get right into it. So we're just gonna carry on with what we call functions. Okay, last time we spoke about functions. It was literally the first time I was teaching functions, because guys, remember, functions. Remember, the way we're teaching functions now, it's a bit different, you know. We are sort of like delving into, you know, the fundamentals, right? The basics of functions. So it's sort of like a blend of, you know, what you guys have been doing in FET and what you did in GET, which is senior phase, okay, grade 8 and 9, right? So I want to introduce you guys to what we call a mapping. Okay, a mapping. So anything that we're not sure of whether it's a function or not, we're just gonna call it a mapping. Okay, we're just gonna call it a mapping. Anything that we're not sure as to whether it's a function or not, we call it a mapping. So in other words, there's mappings that are actually also functions, and there's mappings that are not functions. Remember, we spoke about the definition of a function, right? That when a function is basically when you've got set A and set B, set A and set B. So depending on the relationship between the two, we'll be able to, you know, tell us to whether this is a function or not, right? But obviously this entire thing, we'll just call it a mapping, right? Because there isn't enough information for us to conclude that, okay, this is a function or not. All right, so that's that. So now we know how to address you know, graphs that are not functions, right? We call them mappings. Okay, so I want to introduce to you guys the vertical line test, vertical line test, and the horizontal line test, right? I also want us to talk about one-to-one, all right, functions, also many-to-one functions. Right, so these are the things that I want us to sort of like discuss, and I also want us to talk about restrictions, because there's functions, I mean, there's mappings that can be restricted to become functions. Do you understand? In other words, we know sometimes we look at a mapping and we know exactly what's making it not to be a function. Then we get rid of that, right? Then it becomes a function. Do you understand? So that's just a glimpse of what we're going to be looking at, right? I don't know what we're going to start with, but let's start with one-to-one functions. Okay, so one-to-one functions are normally what we call it's normally the linear functions, exponential functions. These are one-to-one functions, and really the reason why we're talking about we refer them as to one-to-one function is because, like, every element in set A is linked to exactly one element in set B. So in other words, if we had 1, 2, 3, 4, you'd find that this is linked. Let's say this is 1, this is 4, this is 9, and lastly 16. So you'd find that these are directly linked to, you know, just one element. So one element in set A is linked to one element in set B. So there's no such a thing whereby you've got two elements in A being linked to only one element in B, right? Or maybe three elements in A being linked to one element in B, so on and so forth. So that's a one-to-one function. I mean, those are straightforward functions, not so complicated. One-to-one, literally, one element in the first set is linked to exactly one element into the second set. And remember what I said? Set A is our domain. Set B is what? The range. Okay, and we're gonna go right ahead and now talk about many-to-one functions. Right, we're gonna talk about many-to-one functions. Many-to-one function. Okay. Now, what is a many-to-one function? All right, self-explanatory as well. Many elements in the set A. So this one refers to the first set, set A, and this one refers to set B. All right, so many to one. So many elements in this set are linked to only one element in this set, which is set B. This is set A. Now look, this kind of function is so quick example is when you've got y is equal to what? X squared. So we've already discussed this one. So you will see minus 1 minus minus 1 1 minus 2 and then 2 minus 3 and then 3. You will see. So both minus 1 and 1, they're going to be linked to what? They're going to be linked to just 1. Also both minus 2 and 2, they're going to be linked to 4. And both minus 3 and 3, they're going to be linked to 9. Right? So quadratic functions, right, are many to one type of functions. Okay, so yes, those are that's how we classify the different kinds of functions. We've got one-to-one, we've got many-to-one, but as soon as you start having one to many, then this is just a mapping. It's not a function, because you realize that, okay, you'll have a situation like this whereby there's 1, 2, 3, 4, fine, but now you find that 1 is linked to more than one element in the set. So this is A, this is B, right? So let's say maybe we've got 16 here, we've got 20, 24, we've got 28. That is okay. So you find out, okay, when we substitute 1, we are actually getting two values. The first one is 16, the second one is 20. Also, when we substitute, or maybe it's just 1, which gives us two values, and then the rest, they are linked to maybe 3 and 4 are also linked to 28. But really, the thing here, if we can have just one element in here being linked to two elements in B, then that makes it a mapping and not a function. Okay, remember, a mapping, it's a term that refers to, you know, all graphs, irrespective of whether they are functions or not. There's mappings that are functions, there's mappings that are not functions. This is a perfect example of a mapping that is not a function. So this whole thing is a mapping, but it's not a function. Why? Because we've got one element in A being linked to more than one element in B. So yes. So that was just one example whereby we've got a mapping which is not a function, because we dealt with one-to-one, many-to-one, of which they are both functions, but one-to-many isn't a function. Okay, so we have discussed this one-to-one, many-to-one. Now I want us to talk about the vertical line test. Okay, vertical line test. What is a vertical line test? Vertical line test. And obviously this is self-explanatory. We're just going to be drawing a vertical line, but you will see just now how we can use the vertical line to, you know, make some deductions. So look, I'm going to draw the function y is equal to 2 to the x, which is exponential. I'm also going to draw the function y is equal to let's just say x squared, and y is equal to 2x, and what other function can I draw? Hyperbola, y is equal to 1 over x plus 1, or let's just say 1 over x. All right, so this one, obviously it's gonna go like this, an increasing function. There we go. Here it's gonna be 0 is to 1. All right, and then this one, it's gonna go like this, one of the easiest functions to plot. And this one, it's a linear function. It's gonna go like that, passing through the origin. Lastly, the hyperbola branches in the first quadrant. There we go. So now, if you want to run a test, right, just to check if these are actually functions, we're going to use the vertical line test. Okay, so now how do we use the vertical line test? We are going to just, you know, draw a vertical line, right? A vertical line. So here's a vertical line. Vertical line. All right, That's the vertical line, the dotted line there. So you can see that the vertical line actually cuts the function once. All right. So if the vertical line cuts, right, you guys can see, I want you guys to see what I'm writing here. So if the vertical line cuts the graph once, right, therefore the graph is a function. It is a function. Simple and straightforward, ladies and gentlemen. So you just draw a straight line. So here, in fact, here we already have our straight line, which is the y-axis. You can see that it cuts, you know, the graph once. So let's draw our own. It cuts the graph there only once. Do you understand? So this is also a function because the vertical line cuts the graph once. And then let's try this one as well. Also the vertical line cuts the graph once. And then this one as well. Here you can see, even if you drew the line on this side, you can see that it's a one-to-one function. Why? Because the vertical line cuts the graph once. All right, it's not we're not talking about whether it's one-to-one or one-to-many. We are just talking about the number of times which the vertical line cuts the graph. And it's quite clear here that it's only once, meaning that it's a function. It's a function. Okay. A cubic graph is also a function. Remember, a cubic graph is like this. If you've already done calculus, so the vertical line test, right, it cuts once here or there or there. So a cubic graph is a function, right? So that's the vertical line test. Really, you just draw a vertical line and then check how many times it's cutting the graph. But let's see in which case the vertical line is not going to work, right? In other words, a vertical line is going to prove us otherwise, because so far obviously you've seen that what we are getting, it's just function. So let's say we've got plus minus the square root of x. What else can we get that is not a function? Y is equals to what? I can't think of any but I'll think of one. Let's just plot this one in the meantime. So this one, the graph is going to look like this. The graph is going to be like this. Alright, this is what the graph looks like. And now if you check, you realize that if we drew a vertical line, now it cuts the graph here and there. Therefore, this is not a function. It is a mapping, but not all mappings are functions. Right. Also, if we had a cubic function that looks like this, right, that looks like this, if you drew a vertical line, there we go, can see it casts the graph here, casts the graph there, and also there. So this is not a function. It's not a function. All right. So remember what I said. We can actually restrict. We can actually restrict, a mapping that is not a function in order for it to become a function. Do you understand? In other words, now let's suppose that this branch does not exist. Okay, this branch that does not exist. What can we do to ensure that this branch is out? So if we can remove one of the branches and then we remain with just one, then we'll have a mapping. Because in that way, so the simplest way to go about it is to ask yourself, okay, how can I adjust this graph here in such a way that now the vertical line does not cut it twice? Which portion of the graph would you remove so that now you only have one branch? Because there's this branch, then there's also that branch. Then now when we draw the vertical line, it cuts the graph twice. Okay, so if you got rid of this, you realize that now the vertical line will then start cutting our graph once. Or if we remove this one, the vertical line will start cutting our graph just once. Okay, so it's time to play around with this function. Okay, play around with this function. So most of the time we have to adjust the domain. Remember, we've got y plus or minus, right? So if we can say, okay, y should be an element of positive real numbers. Y should be an element of positive real numbers. In other words, y must be greater or equal to 0. Then that means the negative falls away, so our function becomes like this: y is equal to square root of x. Okay, and the only time our graph is positive is if we're only focused on this branch. So our graph would be redrawn like this, would have something like that, right? And then now the vertical line test. You can see that now the vertical line is cutting the graph once. Alternatively, we could have said, okay, no, let y be an element of the negative real numbers. Okay, in other words, y must be less or equal to 0. Okay, then we'd have something like this. Remember, our y is less or equal to 0 from here going down, from here going down. So that means we'd only be left with this portion of the graph, right? And then if we draw a vertical line, you can see that the vertical line only cuts the graph there, which then makes our graph a function. Okay, why? Because the vertical line cuts the graph once, right? So that's just a quick introduction to restrictions. Okay, how you can actually restrict your function in such a way that, your mapping in such a way that it becomes a function. All right, so yes, I think we've gone slightly overboard. I honestly wanted to talk about the horizontal line test as well. Yes, but we're almost done. Let's talk about horizontal line test. So what is a horizontal line test? Horizontal line test. Okay, so with the horizontal line test, this is used to this is not used to test whether a mapping is a function or not, but it tests as to whether the function is one-to-one or one-to-many. All right, not one-to-many, but many-to-one. Yes, so 1-to-1 or many-to-one. So because sometimes you'll be asked the question, okay, is this function many-to-one or one-to-one? And then you'll be like, dude, what? Right, so let's draw. In fact, we can go back to the functions that we dealt with. Remember the functions that we dealt with? Let's just draw a horizontal line. Horizontal line. You can see that the horizontal line cuts this graph once. So this means that this is a 1, 1, 2, 1. But here, if we check, we draw a horizontal line there, it cuts the graph here and there. Right, that makes our graph many-to-one. Many-to-one. And then again we can draw a horizontal line here. You can see the horizontal line only cuts the graph there. So this is 1, 2, 1. Same goes for this one. It cuts the graph once, so it's 1, 2, 1. Right? So if the horizontal line drawn cuts the graph once, then we can conclude that the graph is one-to-one. And if the horizontal line drawn cuts the graph more than once, then we can conclude that the graph is many-to-one. Is many-to-one. I hope you guys are happy. And ladies and gentlemen, we have come to the end of the lesson. I hope you guys enjoyed it. Don't forget to engage and comment. I'll try, as much as I can to respond, and like as well, so that YouTube can, push the content to as many people as possible. Some people don't have teachers and all that, so with your like, YouTube might assume that this content is highly valuable. So yeah, peace out.